Okay, now we have to discuss about different standard normal forms and here PDNF and PCNF. Let us say an example of finding PDNF and PCNF of P conditional R and negation P biconditional Q. That is without using truth table. Okay, thus we can analyze that we can find the PDNF and PCNF using truth table also. It is a simple one and we can discuss it later. Now we have to move on to the solution. Here we have to remember the equivalence laws, which is conditional and biconditional laws. P conditional Q equivalent to negation P or Q, and P biconditional Q equivalent to P conditional Q and Q conditional negation P. Okay, because why we use this rule? Because in PCNF we know that in the middle there will be conjunction, and the conjunction of max terms is the PCNF and the disjunction of min terms is the PDNF. We already know that. Okay, now we let us start with our propositional statement. P conditional R and negation P by conditional Q. We can just use our conditional rule here. P conditional R equal to negation P or R, and our biconditional rule we apply through negation P biconditional Q as negation P conditional Q and Q conditional negation P, which is again we apply the conditional rule to negation P conditional Q and Q conditional negation P. Thus the result become as negation P or R, and here when we apply to negation P conditional Q to the rule as P conditional Q equivalent to negation P or Q. Here negation of negation P or Q, and second one negation Q or negation P. We apply the conditional rules. And again here we apply double negation rule, that is negation of negation P means P, and here we get P or Q, and now the equivalence become as negation P or R and P or Q and negation P or negation Q, which is a DNF, means disjunctive normal form, sorry, conjunctive normal form, not PCNF. Because why? Because here negation P or R and next one P or Q. Thus it is a statements with P, Q and R prepositions. And in the first statement negation P or R there is no Q, and in the second P or Q there is no R. Also in the third one there is no Q, there is no R. So we have to introduce the missing term here. So what do we have to do? Here we know that P and negation P is false. Also Q and negation Q is also false, and in the same way R and negation R is also false. Also there is a result P or F equivalent to P. When we just assign an F here, that is P or F, we get the same preposition P. So when we just here we or with the P or Q and the negation Q, what will be the result? The result with again P. Okay, then we just apply these rules to the statement. That is first one negation P or F means negation P or R. And in the second statement also P or Q or, here again we apply this F, and in the third also. Now we substitute the missing term here. Here negation P or R is here. The Q statement is not here. So we just introduce the Q intersection negation Q to here. Why? Q and negation Q is false, and when we just applying this result here, negation pure, the result will not change. It will remain as negation pure. Okay, in the same way, we in the second or statement also we introduce R intersection negation R. In the third statement also we introduce R intersection negation R. Clear it? Next, we just apply the distributive law while taking negation P or R as a single statement. Then how we apply? Negation P or R or Q and next negation P or R or negation Q. Again, next we are again apply distributive law P or Q or R intersection P or Q pure Q or negation R. Also in the third, negation P or negation Q or R. In the section, negation P or negation Q or R. Okay, here we get the statement like PDNF, means product of max terms. But here there are some more repeating terms. Here we just next we use the idempotent law to avoid the repetition. Okay, by idempotent law we know that P or P equal to P. This we just avoid that repeating terms and we get the PCNF, correct PCNF, and without repeating any max terms. That is, it is the product of max term. Then we have to find out the sum of min terms. It is very simple from it is very simple to find PDNF from the PC. Okay, we know that there are this much combination are there for the max terms pure Q or R, pure Q or negation R. And for three statements, there will be 8 combination of max terms and 8 combination of min term. We write all the combination here and just tick which are the terms in the PCNF. Okay, just tick which are the terms in that PCNF which we already find out. And then just take the min term of which is not in that PCNF. Here P or negation Q or negation R. We just take the max min term as P and negation Q and negation R. Again there is another term which is not in the PCNF, negation P or Q or negation R. And next one P or negation Q or R. We just take the min term form of this one and just what we'll do or it all the term we just join with that or allen or disjunction operation. Thus we get P and negation Q and negation R or negation P and Q and negation R or P and negation Q and R. Okay, which is the form of sum of min terms. Okay, clear? It is very easy to find out BDNF by PCNF. Okay.